Hello and welcome back. We are on episode 50 of our series where we are creating a programming language from scratch. My name's Corey, and during this, you're my rubber ducks. You're the people that I explain my problems to, and hopefully you help me work through them. And as I've said before, let's see, we're writing a programming language named Tang. Stands for template language. It is intended to be a language. The end goal is for a user to be able to write a template of some sort and use Tang to turn that into an HTML page. That is the goal of this. But along the way, I figured why not create a series where we go through and show a way, it's not the only way, but a way of creating a programming language. So I'm doing this 100% from scratch, 100% live coding. That is, I've said nothing up my sleeves. I don't have anything pre-prepared necessarily. I have written a couple of programming languages before in preparation for this, but I'm doing it different each time as I try one approach and it's like, okay, I like this about this one, but I like this about that one, and I hated this about both of them. So just trying something different. And that's what I've been doing. And so without any further ado, we're just going to jump in. And I normally show that, look, if I say git log, the last commit that was made was episode 49, the tagging of that one, which is on GitHub at the moment. And if I say git status, there is a change. And if I say git diff, you'll see all that I've done is I've removed the things in the to-do list that we have finished. So I'm going to git commit that and just say remove completed items from master to-do list. Okay, so that's done. And now we are to our pristine starting place. Not git, make clean, and then make test-watch. Now, what are we doing today? What did I put down on the title screen? I said, using Flex to unescape C++ strings. This is an interesting problem that we need to solve. Well, first of all, this programming language hinges around being able to work with strings. And we're going to have to do quite a bit of interesting work with them. And I want to use Flex for some of this. And the problem is a lot of people think of Flex in really just one way, and that is they think of it as it is a tool, but a way to sorry, I'm just trying to think out loud. They think of Flex as just a tool to just a lexer for the parsing step. And the problem with that is that a lot of times it muddles together in people's minds what Flex is versus what Bison is. And again, Bison is the grammar and finding structure of the tokens that Flex gives us. But Flex can be used in other ways as well. And actually, there are examples of using Flex in different ways online. Can't pull up any at the moment because I just remember finding them when I was trying to create a programming language for the very first time and them being completely unhelpful because it's not what I needed to do. But now that I've messed with Flex a lot for the programming languages, I now understand, okay, what they were trying to accomplish. And we're going to need to use flex in several different ways. So therefore, in my mind, the best thing to do to get started is, for some reason my glasses just don't feel like they're fitting right on my nose, and I don't know why. Oh well, I'll get over it. What was I saying? Yes. We're going to need to use flex in several different ways. So as a warm up, that's where what I want to do. So that is, I want to use flex in a new way, and like I said, it will be a warm up for what we need to do next. So on the left hand, oh, I guess it's still compiling. Don't know why it had stopped. So on the left hand side, we're going to edit the test.cpp. The reason is because I want to show you what is not quite working out how I want it to work out. And if we look for, where are we doing stuff with arrays? The array index, that's fine, but it was with the slicing. The array slice. Did I put that at the bottom? Oh well, it doesn't matter. The point is, for slicing, when we needed to output a string, and I believe we, well, somewhere we did this. Okay, maybe we didn't. Oops. I think I'm just going to add one more test. And this is not a double slice. This will be a maybe that's it. For printing an array, print default, print array. Okay, yeah, I knew I'd had this. And this one right here, where we do the /a. And this was print on an array that contains a string with contents that must be escaped. And what are we going to do? We're going to say a new line, B. And this, I want it to print out as a new line and B. And we're going to see this test fail. Now, what it printed out, what it output, it just passed through the new line exactly. And what I wanted it to do is I wanted it to be, in fact, it's harder to understand it, so I'm just going to use a raw string so I don't have to use any escaping. And And I will do the exact same thing here. I'm going to use a raw string. So no escaping. So I can... oh wait. Maybe it won't read the new line here. There. Now it will. Oops. There we go. And it's still showing the same thing, right? So that there should be an A, new line B, and it's what I want is I want it to actually say /n. I want it to be this /n. Okay. So I'm going to remove the fact that I did the raw string on top. Okay. Still not going to pass the test. But the point is in the context of this line, this /n is converted into actual new line. And when I dump well, I'm saying the word dump, but when I use that as code, the dunder as code that we added a couple episodes ago, it just takes a string and it wraps it in double quotes. But what if there is a quote inside of it? You know, I can add one of these as well. // quote. / quote. Okay. And what this should look like is that it should be that. Well, that's what I want it to be. So you've got a double quote and then a / quote. And it does not do that. And it may be throwing you off because, and by the way, yes, escaping characters does throw off a lot of people, but let's see if I can point out a few things. You see here in the second one, that's the bottom one, it's 0, comma, and then a string that is, so it starts with a quote, and it ends with a quote. In fact, you know what? To make this even more obvious, I'm just going to print out, I'm going to remove the 0 and the 2 because they don't even need to be there. And that way we can see just the contents. And what we'll see is, so it has open square brace, double quote, okay? And we have that here. Open square brace, double quote. Now, when it's printing it out, it is doing what's called unescaping. That is, there's actually only a single quote there, but in order to show that it's a single quote and it's not the ending quote, it puts a / in front of it. All right? And you know what? I had a / here. Yeah, that's what I want it to look like. Okay, sorry, just wanted to make sure. And so in order to show the contents of this one, again, this is the contents of the string, and they don't want you to be mistaken thinking that this one is the closing, so they put a / in front of it, and then it's another one, a double quote that is escaped, but it's double escaped here. That's why you're seeing it as slash 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 close, even though it's not double escaped right here. It's only single escaped. And the point is that our code does not escape or does not unescape. What do I mean by that? Well, escaping is what you're seeing happen here. Unescaping is kind of, it's like going in reverse. It's going from the end result to this expanded format. Okay? And unescaping is not, to my knowledge, natively supported by C++. We have to write our own. We have to come up with a way of doing it on our own. And that's what we're going to use Flex for. Basically, you go through and you say, when I see a double quote by itself, I actually shouldn't write out a double quote. I should write out a slash double quote. Yes. So, let's do that, shall we? Or let's start building this. Now, this test is going to fail. It's going to continue failing until we get something written. And we need to start off with a Flex file for this. So up until now, we've just had one Flex file, Tang scanner. And I've called it Tang scanner because, well, it's the scanner. It's serving as the scanner for the Tang language. So it's not namespacing it. Like, this next thing is not going to be called Tang whatever. Rather, no, that one file was specifically, it is the scanner for the Tang language, therefore it has that name. This next one is going to be a scanner for unescaping. So I'm just going to copy Tang scanner and we'll call this unescape.l. Okay? And let's vim our, oh no, need to back up, our make file because we're going to have to make some changes. So Flex generated files, we're going to add a new one and it's called unescape, right? Unescape, and it's using unescape.l, generating the unescape. Do I want to call? I don't want to keep calling it scanner because it's. Oh well, that's probably fine. And so it's going to generate it, and now I think. Unescape.hpp is going to rely on unescape.cpp in the generated directory. And then in our object files, who is going to use this? So here's our rule to make Tang scanner .o. Where we need a rule for Unescape.o. Unescape.o. Okay. And now, who is going to use Unescape.o? And the answer is our Unicode string. We'll come back to this. So this is 264, but I need to add it to the objects. Unescape.o. Okay. And that was, where did I say, 264? And we're going to say this is going to rely on the generated directory of unescape.hpp, because that's what it's going to pound include. Okay. And it's going to give us compile errors because it's going to say, hey, you've got multiple definitions. That's fine. We'll work with that. But, in fact, let's just jump in. So, Flex, now we've got two files, unescape.l. So we're going to do, we've got, instead of Tang scanner, it's going to be unescape. The prefix Tang unescape. Okay. Everything else should be fine. Don't think we need C standard lib any longer. And this will be, we need unescape.hpp. We don't need the parser. We don't need location anymore. We will be using namespace standard. For YY terminate, couple things. First of all, the point of this, the point of Flex is that, or your scanner of whatever it is that you say, give me the next token. And in the case of our Tang scanner, it says, okay, the next token is a bison object. Well, that's not what we want for this next one. What we want for the next one is that we want it to say, oh, here's the next character. And if it was an A, then it needs to stay an A. If it was a B, it needs to stay a B. But if it was a new line, it needs to be a /n. And if it's something that's otherwise unprintable, it needs to be hex escaped. So we need it to return a string. So what I think that we'll do is we will say, so we're going to pound include unescape, but we're also going to pound include string. And for the YY terminate, I think we could just return an empty string. It returns an int, but we want it to return a string. With our use. Okay, that's fine. So what's the YY user action? Do we even need it? I don't think we need it. Because we're not needing to keep track of where we are. Yeah. So I just think we're going to say D19. There we go. And we're not going to use the states, so we can do away with that. The double %. Do we need any initialization code? I don't think so. Are we returning? Sorry, just thinking out loud. We may not even need the pound include string. Okay. And I think all of that is going away. So let's do this. Let's do, how far can I see? D40. All right. So we know we had to worry about the EOF. What happens when we get to the end? We just call YY terminate. What happens if I see a, whoops, a new line? Whoops, that's not what I meant to do. I meant to do that. Can I do that, or can I just return that? And if I see anything else, return YY text. Now this is just a down and dirty, let's get started. There is no file or directory for unescape.hpp. Is that because I need to create it? I don't remember. So if I look in build generated, there is a Tang parser. Well, that's Bison. There's a Tang. There's no Tang scanner.hpp. There is a Tang scanner.hpp here. This is what we needed. Oh, okay. Yeah, evidently I didn't think through this all the way. We're going to copy Tang scanner and call that unescape.hpp. And now let's edit the make file, because I think the Tang scanner.o. Wait. This isn't ever used. Humor me for a moment. Okay, I'm not going to remove that yet, but it may not need to be there because it doesn't make any sense. Shouldn't this be... No? All right. But yeah, and this... All right, now let's actually edit that file. So we're going to have our flex, unescape, and our include unescape.hpp. So here we go. This is we're Tang scanner. Let's %s Tang scanner, and we will call this unescape. Okay. And we will do the same thing with the title case, Tang scanner, and we will call this unescape. Now we'll get there. Okay. So I'm wanting to double check something to make sure I'm not making a silly mistake. One moment. All right. So this is the flex flexor thing. Instead of Tang flex flexor. There we go. Okay. Sorry, I was looking up. I was trying to find some notes that I had. So for this one, I'm just going to call this Tang unencode. Or does it have to end with flex lexer? I don't think so. For the YY decal, it's going to return a... That's right. A standard string. And this will be Unescape getNext token. Yes, so getNext token is going to return a string. All right. And I don't think I need IOStream. I don't think I need the parser. Unescape, public. This is the input, the output. We just pass that through. Okay, and then we've got instead that we supply, so we can provide a... We don't supply it. This is... Let's see, extract the next token from the input string. Okay, and we return the next unescaped character. We don't need to store the location information anymore. Okay, so no rule to make the target build generated unescape.hpp. So Unicode string. The make file. There we go. This should just be include slash. All right. Oh, and unescape.hpp. Did I just forget to... include unescape. That's on line 61. Oh, I thought I changed this. Did I not? Maybe I didn't. All right. So it's compiled and it's not done a thing. That's okay. So now we can get some work done. So what we're going to do is first we're going to, in our include and Unicode string, we have this class Unicode that we never wrote. How on earth did we never write help text for this. This should be contains a string that is, let's just say represents. Okay, that's fine. Now, we want a function that it is just unescape. Sure, and it's going to take a const standard string ampersand str. And we'll go ahead and write this. It will of the provided string which when provided to Tang equivalent to the originally. Which when, I don't want to say provided, I want to say interpreted by Tang should result in a representation equivalent to the originally provided string. That's a horrible wording. The original source string. All right, and at param is going to be stir the string to be unescaped, and at return the an unescaped version of the provided string. Okay, that's the goal. And we're going to edit the source for, what is this? Unicode string. And it's going to be string unescape. Oh. For the moment, it doesn't actually do anything, but it should compile. Okay, now, where are we going to use this? Well, we're going to look at the source for the computed expression string, and the as code, we're going to have this as a Well, what I was going to say is that's what I want to do. I probably need to pound include Unicode. Oh, I've already got that. Never mind, because I'm using. But it's not going to like this. I know. It's not declared in this scope. Don't think it's going to like that, but not a member of Tang. It should be. Okay. Unescape. Did I just call it the wrong name? Unencode. Unescape. There we go. All right. So it's not doing anything. But now we're going to make it do something. So instead of return string, so let's see. Pound include an escape. I think that's right. And now, what will this look like? So I think, you know what? GitHub, Tang, Tang base. Okay, so it's the program that runs the compile. So program.cpp. There we go. That's what we need. The parse. Forgotten about a lot of this code. Okay. So I'll put the parse over here. This is our own code that we have written on this string. So string stream ss using stir. And then what is the type? Unescape. No. Unescape you. And I'm going to give it ss. Sure, we'll just give it cout. I can deal with that. I'm probably going to have to pound include IOStream. That's fine. I don't need the error. I don't need that. Okay, so that's as much as I can get from here. Now what I need to do is I need my an output string and a next, and I will say while next is equal to u dot get next token, which it should return a string dot length. So I'm just saying while there's some size to it, out plus equals next return out. Is it that simple? I don't need this. I just needed it to, I couldn't remember how to instantiate it because I've only done it once in this stream, and that was 48 episodes ago, maybe 49 episodes ago. I don't know. So the Unescape is going to convert the string into a string stream, and that's instantiating it, yeah. And then we have a buffer, the output buffer, and then next just holds the next one. We call get next token, and that gets put into next. And while there is some length to it, some size, we just append that to out, and then in the end we just return out. Yes. Okay, it's going to not like some stuff. It's going to probably say an initializer but incomplete type. What? I mean, we're using strings elsewhere, so that should not be a problem. Does it not like the fact that we have string streams? Okay, I guess that was one of the problems. And now the compile says Unescape undefined reference to Tang unencode, Tang unencode. Oh, so it's saying it doesn't know where to find the Tang unencode, Tang unencode. Just means I forgot something somewhere, I'm sure. So that's this here. That is this line. And it's saying it doesn't know where to find it. All right, so all right. Oh. Yeah. It's just called Unescape instead of... Okay. So... look at my old one and just see if there's a naming issue. Oh. So this is, I had forgotten, but I talked about this a long time ago, and that is that the YY Flex Flexor is, we're just defining it as a new name, and it's going to serve as the intermediate type. And so Unescape will inherit from that. So that should be good. And it's still saying undefined reference to the Unescape Flex Flexor. Doesn't know. So did I just... Oh, when compiling Unicode string .o, no, Tang test. Oh, Tang test, that's right. Because the... This one... This is the Unicode string test, and we treat this one specially. Yeah. Okay. Makefile. Go to the bottom. For the string test. There we go. In fact, we can see it. We have to specifically include Unicode string and obj object directory unescape.o. And this one is, so Tang test. It is including unescape.o. You can see it there. And this is for, yeah, the output. Okay. Undefined reference to Unescape Flex Flexor. Escape. So it's not liking that. In unescape.hpp, line 54. So it's saying, Corey, you're defining it, you just haven't written it anywhere. I want to go back to the stuff I wrote. We've got all of this. I'm wondering is when I declared, looky there, did I just leave that out? No. So, okay. So what it's saying is when I'm saying YY flex lexer, it is interpreting that as an escape flex lexer, and it's saying, hey, I don't know what that is. So that probably means in my flex, I think. LEXER. Is this a separate? No, it's not. Why is it always compile errors? This is the problem with using projects, is that sometimes they're just messy to incorporate. That's why this video is here, right? To show you how that, or rather to show you that evidently I don't know how, and we'll figure it out. Unicode string.o in escape, undefine reference to an escape flex lexer. And in the deconstructor, undefine reference. That makes me think that it's not including the object file. That's what it sounds like. So, how do we get the unescape.o? That is made up of unescape and unescape.cpp and the generated unescape. Okay. Now, who uses unescape? Object dir unescape. So the Unicode string uses it references the include unescape. Okay. Unescape.o shows up here, which is in the test Unicode string. And it shows up in the lib object, so it's being compiled into the shared library. And there. So I'm probably not naming something correctly. That's my working theory at the moment. So what I'm going to do, remove it all, start again on the compile. That is, just so I know what's compiling, what's not. Okay. Unicode string.o compiled. Tang test cannot find build objects. I'm looking to see if I call it unescaped, you know, with the D at the end. No. So it's saying it can't find build object unescape.o. So, which one is this? Tang test. This one here. Wait a second. Why are they both called Tang test? This should be Unicode string test, which is probably compiling Unicode string test. Yep. Okay, so that's the one it's not working on. Unicode string.o. Okay, so it's still undefined reference. Okay. So what are we doing wrong? Unescape flex lexer. Unescape flex lexer is saying it doesn't know where that is. So, if we look at our source code, for our Tang scanner, we have our tangscanner.hpp. You know what? Let's just do this. tangscanner.hpp. And I also want flex tangscanner.l. Between the two of them, we've got this tang flex lexer. Do we have the same thing here? Is that the thing? Does it appear anywhere else? No. So, what I'm wondering is then if it needs to be Tang unescape flex lexer, and this is Tang unescape, but in the other one. So in this one over here, vim flex unescape and include unescape. So that is Tang unescape. So the class name does not need to match, but this does. Tang Tang, and then this is Tang Tang Flex Flexor. Tang Unescape. That's it. It was a naming issue. All right. So, not the include, the source for the Unicode string. What I think, unescape, all that we're going to do, instead of return out, 3 X's. Why not? Like in the cartoons, that's what they labeled the booze, because it was bad. It's dangerous. Look, it is coming through. Okay? Now, so that's fine. I'm going to see out that's just so I can see it, because this is unescaping. I don't want to see it double unescaped. This is just for a moment. Okay, the output in the case of the first one is A, and the output in the second one is A slash N B. You know what? All right. That means we got the slash N, and look, it's being double escaped. So, I mean, that's just Google Test is performing a second escape. So the only thing that we're missing, I think, is the slash. And in order to get that, I need to edit flex unescape. So if that's a slash N, a regular slash should be 2 slashes, but I'm having to escape that. Oh wait, that's not the one I needed. I need a single quote. Actually, I have to escape it. We passed. So I didn't need to escape the slash, or at least not for that test. Now let's actually write some actual tests. and some tests for this. So what is that going to be? So I'm going to edit test Unicode string, and then we're going to reopen flex Unescape. And so this is the test Unicode substring. You know what? We'll just say test, and what is this test going to be? This is going to be Unescape, or how about core Unescape? There we go. And string s All right, so this will, I just want to see if this compiles. Of course it doesn't. I didn't give it a string. Well, now I have a string for it. It does compile. So does an empty string cause any problems? No. It returns nothing. What if I give it an A? Does it return A? Yes. In fact, ABC. In fact, let's just do this. Nine, and what else? A period. Actually. As I'm not the backslash. The backslash requires special work, but that's the pipe, semicolon, colon. What other characters should I be able to see? That, comma, period, that and that, question mark. That's everything on that passes. So everything in that list is passing through unaltered. A new line. Does that come out as a /n? Yes, it does. And I just added a letter so that we can see it fail. And you'll see, yes, it is double escaped. But that's because I wanted to show it. Yeah. What else needs to be escaped? That's the question. So now it's time to do some searching. Now I had my thing of patterns, even though I haven't used them yet. how do I want to do this? I think I want to say C++ escape codes, escape sequences. Excuse me. Now, I don't need to support all of these, but there's a couple I do want. I need I've already got the new line. Let's do a backslash quote, and that should come out as a backslash quote. A backslash A, that's an audible bell. Backslash A. Backslash B, which is quite a literal backspace. Backslash F for form feed, should come across as a backslash F. Backsplash, well, that's new line. Let's just put it down here. And so new line R for a carriage return. And a backslash T for a horizontal tab, and then a backslash V for a vertical tab. And then we're going to do, I'm not going to do anything other than all right, so what does this represent? This represents the hexadecimal value AA as a single char. And that should come across as an escaped /XAA. So the idea is that we're wanting to escape things that we don't recognize. Basically, anything that's not in this list should be turned into either a known escape code, which you see them here, with the exception of I'm not including the single quote or the question mark, or it should become one of these hexadecimal escape codes, because our program should understand all of these. All right. That's the goal. So I'm going to say write this, and now tests should fail. And they do. Okay, so it's saying it doesn't understand the A, B, F, R, all of those. But we're going to write that into flex. And that's just right here. So, just like we did this with the new line, you've got the A, B, F, R, T, V. Okay, so this is going to be A, B, B, F for the form feed, F, carriage return, tab, tab, vertical tab, vertical tab, and okay, that's just a standard backslash. Okay. Flex is not giving me any errors. That's good. And now the only one I have left is this unescaped value. Excuse me, the hex codes. Okay, this is a problem. Why is it a problem? Well, because right now I've got a catch-all that just returns YY text, and I don't want that. I want my catch-all to be the hex value. So I've got a character class here that says match one of something in here, and it's just going to be return YY text. And then what goes in here? Well, this is not going to work. Whoops. Because some of these characters are special. So, for example, in order to have, well, I just had this showing. So any character except the new line is a period. So in order to get a period, I have to escape it. This is a character class of A, B, J, 0, Z, yeah. Negated is with a caret. See, it even has special provision for these slashes. And what I'm thinking we're going to need to do, I'm going to say A dash Z A dash Z 0 dash 9, and then I don't think the exclamation point shows up, but so what does? Make it large enough so I can see. How about that? See the caret, but is it only the caret when it's when it occurs first? I think so. I'm pretty sure that these need to be escaped. The or, the pipe, because that's normally an or. Semicolon should be fine. The period should be question mark. I don't think these probably need to be. The asterisk, definitely. Well, you know what? Let's just see what it gives me. Does it complain? No, it did not. Okay, so now here's the question. If I, instead of saying return YY text, if I say return the triple or 2x's, it matched none of them. Now, let me just show you one other thing. Let's just say I do that. What I think we'll see is that some of the stuff will bleed through. Yep. A through Z, 9, but nothing else. So the question is, if I add the exclamation point there and remove it from here, what's going to happen? Does the exclamation point break it? No, it works just fine. You can see that by it recognized it. So there's something in this list that it doesn't recognize. Simple enough. Okay, so let's add @$. And we'll just say @$. Remove those. Go 3 at a time. Why not? I recognize @$. Those ones are there, so they came through just fine. So % is probably going to come through okay. We're getting into some of these, I'm like, oh, I'm not sure. % came through. The caret has come through. So here's what I'm going to do. Let's do this. And I'm just going to say there. Nope, I didn't mean to do that. I meant to do everything after that. All right, so now this will be from there to there. So that will be everything up to the pipe. Semicolon and everything up to the period. Okay. Bad character class on line 108. 2 slashes. Okay. Do I still need... Wait, everything passed. No, don't do this to me. Okay. So I should have saved the original, but I did not. So the question is, do I still need it before the ampersand? Nope. All right. So I'm about to combine some of these. That should be everything in one line. Oh, I missed one. It's okay. We're still... Oh, you know what? The space. I didn't include the space. Well, I did just then. In fact, here, I'll put it at the end. And I need to include it here. We'll put a space there. And a space there. Okay, so did that recompile? Yeah. We know it's working. How do we know that? Because, well, everything except the hex at the end. Because everything came through unescaped, or everything came through without being escaped. And the XAA is being replaced by the 2 X's, which is the last thing we're supposed to do. So, how do we convert that into a... Whoops, wrong window. So we know that we need a char buff of size /x something something null terminator 5, all of which are zeros. Forget that. Let's do /x 0 0 there. Return buff. Still not going to pass, but, well, you'll see. Now we've got /x00 instead of XAA. Okay. All I'm going to do is now say if YY text sub 0 is greater than 15, then I do one thing, else I do something different. I will say, so what is the something different? Well, if it's less than 15, then I only have to, then it's just one character, and I can say char is ch is equal to, and what I want to know is YY text sub 0 greater than, no, we'll do that. And now ch is equal to, ch is greater than 9. If so, then it's going to be, so if it's greater than 9, then we're going to say capital A plus ch minus 10. Okay, and what that is going to do is that says, so imagine ch has the value of 11, b hexadecimal. If that means, so if it's greater than 9, it's going to say the a plus 11 but minus 10. So a plus 1 will turn it into a b. Yes. Otherwise, it's going to be 0 plus ch. Simple enough. And then we'll say buff sub 0 is the slash, 1 is the x, 2 is the 0, 3 is the one that we want to be equal to ch. Now, that's not going to fix our problem, but it will if we write a test for it. We could do slash x 0, 0, and that should show up as a slash x 0, 0, and slash x 0, 1 should be a 1. Those should show up, correct? Now, why does it not catch this? Because I need to tell it specifically that it's a string of length 1 because it's detecting a null terminated string. There we go. And did that work? 26 is failing. Wait, 27. No, 25 and 26 are failing. 27 passed. Here, I can show you. This one, if I add an A to it. Yeah, it did properly encode. So the whole point was, it was converting it to a string, but since I was giving it a null character, it read it as a 0 length. And it's like, no, I want a 1 length that has a null as the first character. And so I just had to give the string constructor, or call it explicitly with a length. Simple enough. All right, and 1 came out correct. And now we've got the big numbers, right? A and F, and those are not working yet. So we're about to do those. I don't think I need to do the ifs here at all. I think I'm going to do a char ch, okay? And so what I'm going to do is I'm going to do the high order, the upper 4 bits followed by the lower 4 bits. Okay, the lower 4 bits is basically YY text sub-0 and with an ampersand of slash well, it's the first 4 bits, so 15. A bitwise operator. And we're just saying, there we go. So buff 3. But for this one, it's going to be, and what is, well, it's easy to do this. 15 shifted right 4 times, and then shifted left 4 bits. So I'm getting the high order ones, and then I'm shifting it down, and the exact same logic will work. I just put that in buff 2. I think. Oh, did I not? Did I not save it after changing that? There we go. It is all passing. So that thing that you just saw a moment ago, all of that was just to convert it, anything I don't recognize, into hex. Now, the other thing I'm going to do is I'm going to say this 1 or more times. Why? Because there's no reason to do it individually when I can do them, you know, I could do a big group of them. So there we go. There we have it. We now used flex for something other than parsing a language. And that is, we just used it to really break up. It's doing the same thing. It's tokenizing a string, but it's doing it in one pass through. I don't have to say, okay, now look for this and replace it with something else. Rather, I'm saying when you find whatever, and in this case, it's if you find a single quote, you know, replace it with something that's longer than a single quote. And I'm doing that with several of them. This line here will find as many things as it can in here. So, for example, I will see out YY text and line, and I'm just going to say found something, okay? Just so we can see it run. The whole point is just so you can see it put a bunch of them together. A, B. Oh, here it is up here. These were just single character things, I know that. But this one, it found that entire length in one go. And no, the order does not matter. And how do we know that? Well, because if you're just dying to know, or if you're just dying to see it, I will move the Whoops, didn't mean to do that. I will move the A there. Now it's going to fail the test, right? Because, yeah. It says, but it did find B, A, C, so it doesn't matter about the order. But it's saying, hey, it doesn't match because, well, I had A, B, C. And so, you know what? I'm just going to, here, I'll put the A second. So that it intentionally, we know it works and we know that we found the right thing. And now delete that C out. And I also don't think, well, I've got unescape.hpp. Yeah, okay, that's fine. And it works. All right. Well, how are we doing on time-wise? Ooh, almost 2 hours. Let's wrap this up. So, got our scanner. We've got our unescaping stuff. We've got all of our rules. And again, big picture. Why did we spend so much time on this? Well, because in the future, coming up pretty soon actually, we're going to need to do other things. We're going to need to say, here's a string. I want to output it as an HTML encoding. So anything that could be dangerous in HTML is escaped. Well, that's a perfect application for this. What about, oh, and by the way, I've already started compiling the list. It's big. I mean, like thousands of encodings that we have to be aware of. This is perfect for that. Is there anything else? Sorry, brain stopped working, but it's because I'm thinking. Yeah, brain stopped working. But so that's just the HTML encoding. Then there is percent encoding that we'll need. And then there's, well, for that matter, we will probably also need a percent decoding. Maybe not as much for this project, but it is for a related project that I would want to include that capability into this set of libraries. But again, it's the same thing. It's as you chew through different parts of the as you chew through different parts of a string, then you do some sort of analysis or transformation, and that's what Flex is good for. So, unescape, include, unescape, and now we're just doing it all in one big commit, and this is add unescape output formatting when printing or for use by computed expression string.dunder as code. Yeah. Usual things, make docs PDF. What episode are we on? Was it 50? Yep, episode 50. Okay, so for episode 50, oh wait, usually I want to make sure that it's actually still working. Waiting for the compile to finish so that I don't have to undo this commit. Everything passed. That's always a good thing. Episode 50. And we pushed it. Where does this put us? 6247. It's growing. You may remember I had said that I thought it would be about 10,000 lines of code. And I don't know. It may be. It may reach that. It may not. We'll see. Still have a lot of stuff to do with objects, with native functions and bound functions, and so that we can do things like after you have a string, say dot length, and get the length of the string, and optimization of the bytecode, right? We could do stuff like that to simplify bytecode, and yeah, so many good things. But for the moment, I think it's bedtime. Yeah, this one's 2 hours. I don't remember if this is the third or fourth video I've done today. But the whole point was I just wanted to get some content out and get caught up on the fact that I missed 5 days of recording because I couldn't. Yeah, it was last week, but I finally figured it out, and I have not updated my Stack Overflow question yet with the answer that I found. So I need to do that too. But as usual, thank you for joining, and I hope it was beneficial to you in some way. Thank you. Bye.